This training is presented to principal investigators, supervisory personnel, staff, and other stakeholders at Georgetown. The program was developed to address employees' right to understand the hazards on campus. New changes to the Occupational Safety and Health Administration's, or OSHA's, Hazard Communication Standard are bringing the United States into alignment with the globally harmonized system of classification and labeling of chemicals, further improving safety and health protections for America's workers. Building on the success of OSHA's current hazard communication standard, the GHS is expected to prevent injuries and illnesses, save lives, and improve trade conditions for chemical manufacturers. The Hazard Communication Standard in 1983 gave workers the right to know, but the new globally harmonized system gives workers the right to understand. The elements of a hazard communication program include an up-to-date chemical inventory, a written program that establishes how the requirements are to be met, hazard assessments of chemicals used by employees, access to safety data sheets, proper container labeling, and training. This effort must come from all of us. This safety training will help provide us with the knowledge we need to eliminate the biggest hazard source, ignorance. The Hazard Communication Program has historically given workers the right to know, but the new globally harmonized system gives workers the right to understand. Information must be provided to users, but must be as simple and intuitive as possible. Objectives of the Hazard Communication Program include: develop a listing of all chemicals in the workplace, classify chemicals based on hazard, establish a procedure for new chemicals manufactured or distributed from the workplace to other entities, implement effective labeling of chemical containers in use in the workplace or being shipped to other businesses or work areas, disseminate safety data sheets and make them available to employees, as well as prepare and distribute SDSs to other entities as required. Devise a system for providing information and training to employees on exposure to hazardous chemicals, protective measures that can be taken, and other facets of the OSHA Hazard Communication Standard. Communicate relevant hazard information to outside contractors or other employers that may work on-site or in conjunction with the employer's hazardous chemicals.
Everyone working around hazardous chemicals and other toxic substances has a right to know of possible dangers and how to protect themselves. Ensuring that everyone knows the potential risks, what to do if exposed, and how to respond have always been at the heart of OSHA's Hazard Communication Standard since it was issued almost 30 years ago. Since that time, the HAZCOM standard has been saving lives and protecting the safety and health of employees and employers in workplaces with potentially serious hazards. Thousands of injuries, illnesses, and deaths have been prevented because of the training, labeling, and information required by this rule. Now it's time for another step. OSHA is making good protection even better. With the strong backing of manufacturers, employers, and unions, OSHA is raising the bar, improving safety and health for everyone. We are updating HAZCOM to meet the needs of our changing world. Today, we live and work in a global environment. Different and sometimes conflicting national and international requirements can create confusion among those who need important, clear, concise information to protect themselves as quickly as possible. To help make this happen, we are incorporating the globally harmonized system of classification and labeling of chemicals, GHS for short, into our HAZCOM standard. In taking this step, we're joining the ranks with other nations to upgrade protections, standardize hazard communication, and reduce trade barriers. It's a win-win that will benefit all, and after implementation will save millions of dollars each year. Historically, under HAZCOM, there were no firm rules for what a label or material safety data sheet should look like, or how information was presented. Now, under the new standard, instead of having a variety of different safety data sheets and labels, the hazard warnings will all be the same regardless of who produces them or where they're produced. And even more importantly, the message is the same regardless of who sees it. There's a big difference. The new labels alert people to potential hazards and provide important details on how to handle chemicals safely. They tell you not only what you need to know, but also what you need to do in a way that everyone can clearly and easily understand. Here's an example. In the past, warning labels for a toxic chemical could look like this or like this. Both of these sample labels for the same chemical would have been in compliance with OSHA's requirement. But now, under the new updated standard, a prototype label would look more like this. In fact, this step represents more than just pictograms and labels. It's a whole new system, one in which everyone is using the same underlying criteria to classify chemicals. Behind every image are uniform organization and classification systems that spell out the potential hazards and protections in terms that everyone worldwide can understand. Whether you're working with chemicals, manufacturing them or transporting them, or supervising employees exposed to them. In this new system, every hazardous chemical and substance not only carries a uniform label with information that is easier to understand, but also provides warnings that are clearer, necessary action more obvious, and protections readily apparent. In short, the new HAZCOM standard, now aligned with GHS, will provide a simple alert system to save lives and prevent injuries and illnesses worldwide. The new system has been years in the making. It's already a reality in a growing number of countries, and even more are taking steps in the same direction. This harmonized international system will help reduce trade barriers in the global chemical market by aligning the U.S. with Europe, Asia, Mexico, Australia, New Zealand, and many other nations. When the HAZCOM standard took effect in 1985, workers got the right to know. That is, the right to know what the potential effects of exposure to hazards might be. But the right to have labels or material safety data sheets did not always mean that it was easy for workers to understand that information. Today, with the new globally harmonized standard, workers are now getting the right to understand. That means not only knowing about potential hazards, but also better understanding what the warning means, what to do if exposed, and how to protect oneself. With this new system, workers in the United States and workers worldwide will have the same simple, concise information they need to understand how to prevent injuries and illnesses and save lives. Nothing could be more important than that.
This refresher module will present 6 segments pertinent to hazard communication. These segments pertain to responsibilities of all GU employees working with chemicals. All GU employees, before beginning any work with chemicals, must understand regulatory and practical applications of HAZCOM, determine potential hazards depicted on a label, know OSHA's 8 pictograms which apply to specific hazard categories, apply the data from labels and safety data sheets, take proper course of exposure minimization action according to precautionary statement, and determine safe approach according to specified hazard statements provided in safety data sheets. To fully understand the important functions of the hazard communication standard, it is important to grasp the regulatory applications and practical applications. Information about the hazards of a substance are transmitted via the administrative controls, which are an inventory, container labeling, safety data sheets, and employee training. All of these are required by the hazard communication standard. Practical applications are provided by the lessons learned from history. In 1917, Halifax, Nova Scotia was a Navy base and a major hub of wartime activity, and Halifax Harbor was crowded with warships, troop transports, and supply ships. A tragedy happened in December of that year. It resulted from ineffective communications of explosive hazards. In the end, more than 1,900 people were killed, 9,000 were injured, 1,600 buildings were destroyed, 12,000 houses were damaged, 6,000 were homeless, and 25,000 people were left with inadequate housing. What contributed to this? The Belgian relief vessel Emo was leaving Halifax Harbor on its way to New York, and the French munitions ship Mont Blanc was on its way to wait for a convoy when the two ships collided at 8:45 a.m. The munitions ship was carrying picric acid, gun cotton, and TNT. The top deck carried benzol, which spilled and burned. The Mont Blanc rammed a pier, setting its wood pilings on fire. It then exploded, flattening everything within 800 meters and causing damage for 1 mile. The explosion was said to have been heard as far away as Prince Edward Island. Fire spread quickly after the explosion. Water around the ship vaporized. A huge tsunami wave flooded the streets of Halifax and Dartmouth and swept many people back into the harbor where they drowned. The hazards were not communicated, therefore not understood. Red flags were normally used prior to the war, but this would advertise cargo to the enemy. An alternative means was needed, but not developed. The people in Halifax that day had a right and a need to understand. The ideas behind hazard communication began to develop and have evolved to the GHS system we have today. Next, we'll look at the necessity of determining potential hazards shown on labels. Chemical manufacturer requirements include providing a label with information that a recipient will rapidly and completely understand. The new hazard communication standard still requires chemical evaluation and the provision of hazard information to employers and workers by putting labels on containers and preparing safety data sheets. However, the old standard allowed chemical manufacturers and importers to convey hazard information on labels and material safety data sheets in whatever form they chose. The modified standard provides a single set of harmonized criteria for classifying chemicals according to their health and physical hazards, and specifies hazard communication elements for labeling and for safety data sheets. Under the current hazard communication standard, the label preparer must provide the identity of the chemical and the appropriate hazard warnings. This may be done in a variety of ways, and the method to convey the information is left to the preparer. Under the revised HCS, once the hazard classification is completed, the standard specifies what information is to be provided for each hazard class and category. Labels will require the following elements. When a chemical is transferred from one container to a secondary container, that secondary container must be labeled with the name of the manufacturer and some indication of the primary hazard. Product identifier, the exact name of the subject chemical product. Pictogram, a symbol plus other graphic elements such as a border, background pattern, or color that is intended to convey specific information about the hazards of a chemical. Each pictogram consists of a different symbol on a white background within a red square frame set on a point, the red diamonds shown on the slide. There are 9 pictograms under the GHS, however only 8 pictograms are required under the standard. Signal words, a single word used to indicate the relative level of severity of hazard and alert the reader to a potential hazard on the label. The signal words used are danger and warning. Danger is used for the most severe hazards, while warning is used for less severe hazards. Hazard statement, a statement assigned to a hazard class and category that describes the nature of the hazard of a chemical, including, where appropriate, the degree of hazard. Precautionary statement, a phrase that describes recommended measures to be taken to minimize or prevent adverse effects resulting from exposure to a hazardous chemical, or improper storage or handling of a hazardous chemical. Supplier information, the precise location of the provider. There are a variety of ways to label a secondary container. This includes the NFPA 704 rating system, Hazardous Materials Information Systems, Department of Transportation labels, or by simply writing the name of the chemical or product and the primary hazard. Example, ethanol and flammable liquid. The next part of our module is a description of OSHA's pictograms to provide understandable data on hazard categories. The Hazard Communication Policy provides detailed explanations of the various pictograms and statements that will come via safety data sheets and safety labels. There are 9 pictograms provided, where applicable, in SDSs or labels. The health hazard, for chronic hazards affecting the system. The flame, for such things as pyrophorics or organic peroxides. The exclamation mark, for irritants or acute hazards. The gas cylinder, for pressurized gases. Corrosion, for skin burns and eye damage. The exploding bomb, for certain self-reactives and organic peroxides. The flame over the circle, for oxidizers. The environmental hazard pictogram, for chemicals which cause aquatic toxicity. Skull and crossbones, for acutely toxic chemicals causing serious effects. Next, we'll discuss how to apply the data from the labels and safety data sheets. The NFPA diamond is often shown on products and SDSs. It provides employees with information regarding the highest hazards for each category, namely health hazard shown in blue, fire hazard shown in red, reactivity shown in yellow, and specific hazard in white. Specific hazards are provided with letters and symbols rather than with hazard scores. This allows employees to make the proper precautions. More information can be obtained by searching for detailed hazard information and controls. Note here the numbers in each smaller diamond. The degree of hazard goes from 0 to 4, with 4 being the highest hazard. The hazard degree is usually assigned by the manufacturer or supplier of the chemical. The NFPA provides guidance on what values to assign to a given chemical. The bottom quadrant is reserved for special hazards. An example here is a W with a line through it. This indicates a material never to be combined with water. You should never fight a fire in this area with water. This is called a water-reactive chemical. For the fire hazard, anything with a rating of 3 or 4 would indicate that the chemical is flammable liquid, while a chemical with a rating of less than 3 would be considered a combustible liquid. As mentioned previously, with the NFPA 704, 0 is rated the lowest hazard and 4 is the highest. It turns out that the GHS classification system uses a different rating system to indicate chemical hazard danger. Typically, the GHS uses 1 to 5 to mark the hazard rating, with 1 being the highest hazard and 5 being the lowest. The important thing to remember is that the rating method between the two systems are different. To help out with this confusion, OSHA has created a quick card with additional guidance on the differences between the new GHS system and the older NFPA 704 system. To explain the particulars regarding the NFPA 704 and GHS, OSHA and the NFPA developed this card to be used as guidance. This is a useful tool for the compliance in your work area. Please note the website where you can download this tool. The same website will provide specific information on developing labels for both purposes. The GU policy for hazard communication includes guidance for labels. There are pictograms, categories, signal words, hazard statements, and explanations on product labels. In this example, for a carcinogen, hazard categories are provided with associated signal words, pictograms, and hazard statements. Also included are background data on the hazard categorization. In the case where you have particularly hazardous substances in these categories, you would understand that there would be a need to have a standard operating procedure developed for this type of substance. This is covered in the chemical safety module. A safety data sheet must be maintained for each hazardous chemical used or stored. Employees must have access to the SDS at all times. Exceptions include the use of consumer products when the product is used as intended by the manufacturers. For example, an SDS is not required for Windex as long as it is used for cleaning windows. However, if Windex is used for cleaning some processing equipment, an SDS must be maintained. With the GHS way of standardizing information, the user now has efficient means for readily understanding the chemical hazards. All manufacturers will provide the SDS with similar information according to the specifications of the Hazard Communication Standard. A chemical provided by one manufacturer will have the same information in the safety data sheet as that provided by another manufacturer. This ensures that hazards are managed appropriately wherever this material is used. Oftentimes, the mixture is the cause of the significant hazard. This example SDS is chloroform stabilized with aniline. The sections of this SDS are in accordance with those provided in the OSHA guidance. Of special note here is Section 5, Firefighting Measures. As shown, the chloroform stabilized with aniline can emanate phosgene after an amount of time. Phosgene was used extensively during World War I as a choking pulmonary agent. This lesson learned provides direction to labs in how to avoid the generation of dangerous phosgene when storing chloroform. This excerpt from the SDS for dimethylmercury directs workers to handle with gloves. The type of gloves that are used can be of paramount concern. More information is needed. This lesson learned provides an account of a fatality involving dimethylmercury. This illustrates the need to go beyond the SDS for sufficient protection. In similar cases, the permeation degradation resistance guides are provided and can help enable workers to be sufficiently protected while working with the material. Though the safety data sheet can lack some key information, it is important to make sure that all avenues are covered. For example, what type of gloves are appropriate? In the OSHA guidance document on dimethylmercury, we learn that certain gloves must not be used. The right approach can be learned by communicating with your safety organization. Lastly, we'll look at how you can arrive at safe management of a chemical by looking at the hazard statements in the SDS. Hazard statements provide direction for PIs and lab staff to manage exposures using engineering controls, administrative controls, and personal protective equipment. In the case of isoflurane, an anesthetic gas used in several locations, one key hazard statement is, may cause damage to organs in the cardiovascular system or central nervous system through prolonged or repeated exposure if inhaled. OSHA has not established a permissible exposure limit for anesthetic gases. National Institute of Occupational Safety and Health has a recommended exposure limit for halogenated agents of 2 parts per million or 15.1 milligrams per cubic meter as a ceiling limit. Under the isoflurane SDS, a statement is provided that it contains no substances with occupational exposure limit values. In fact, the NIOSH recommended exposure limit exists and should be used for evaluating protective measures in the lab. As you may conclude, it is a good practice and occasionally necessary to explore references additional to safety data sheets when researching hazards associated with a chemical. This flowchart shows the value of developing a standard operating procedure to implement control measures in advance. When obtaining the information from safety data sheets and analyzing the steps of a task, hazards can be eliminated and risks drastically reduced. You will understand the value of the standard operating procedure and combined efforts with safety when you review the chemical safety module. The hazard communication efforts feed into this critical task, and when adequate and complete, the goals of a resumption of operations and improved safety are achieved. An illustration of a time-weighted average is shown here. With a goal of 1 part per million, half the recommended exposure limit, the exposure shows 1.5 parts per million for 3 hours, 1 part per million for 2 hours, 0.25 parts per million for 2 hours, and no exposure for 1 hour, perhaps due to lunch break. Has the worker been exposed to above 1 part per million of isoflurane? Calculating the exposures over an 8-hour shift results in a time-weighted average of 0.84 parts per million. This is less than the 1 part per million exposure goal, so no exceedance has taken place. The determination of exposure must take into account the entire time frame. In this example, a working day. Had the exceedance taken place, engineering controls, administrative controls, and personal protective equipment must be evaluated. Corrective actions were illustrated in the case of isoflurane, which involved relocation of the apparatus. With the arrival of a new chemical to a lab or other workplace, what should stakeholders do to maintain compliance with the hazard communication standard? The employee will receive incoming chemicals and examine for adequacy of packaging. review label for pertinent information, and retrieve safety data sheets from shipment and provide to supervisor. The supervisor will place SDSs in appropriate binders in alphabetical order and conduct safety briefing with affected employees concerning hazards associated with the chemical. The safety organization will conduct annual training via web-based or in-person on the OSHA HAZCOM program and inspect work areas to ensure safe storage and maintenance of SDSs. In conclusion, you must work with the rest of the university to conform to the requirements of the Hazard Communication Standard. This responsibility is critical for minimizing incidents involving hazardous chemicals. It is your responsibility to conform to the requirements of this standard, but you may call the safety offices for any assistance you may need. Thank you for contributing to Georgetown University's Hazard Communication Program.